All right, welcome everybody. Thank you so much for joining us today. We're really excited to present some of the content that we've prepared here that basically centers around what's the deal with large language model app development in 2024. And so if we go to the next slide, joining us today, myself, I'm the VP of Engineering at Arthur, and Max Cembalest, who is a machine learning research engineer here at Arthur. And we are really excited to walk you through some content around what both we have seen from developing our products, what the tools, techniques, best practices, some new exciting things in the field are, as well as across our customer base, how our customers are thinking about leveraging and utilizing some of these tools to get started in realizing value with these applications. Before we jump into it, if you can, next slide, please. I just wanted to give a brief overview of sort of like what we do at Arthur and why this matters for us. And can we just skip through all the animations here, please? Fantastic. So, at Arthur, we develop a handful of products that center around the software development lifecycle of machine learning applications. And so within the context of generative AI and sort of large language models, that really boils down to the whole life cycle around how do we evaluate and pick the best model, the best prompt, the best hyperparameters for a particular task. When that model has been chosen and you're leveraging it within an application, like a chat application, how do you protect and prevent, and sort of govern that interaction to make sure things like hallucination, prompt injection, PII sensitive data isn't leaking? And then finally, after you've deployed that and you're sort of monitoring it in real time, how do you think about observing that behavior, capturing particular interactions, or like being able to investigate or analyze the decisions that you've made? And the sort of the real thing here is these applications and sort of the workflows and the machine learning that is being brought to leverage here is a continuous task. Like these things are always happening in the background. You're always going to be evaluating, especially with how frequently some of these new tools and new foundation models are released. You're always going to want to govern these things. The way in which you govern them is definitely changing over time. And that observability piece is something that is so critical and underlies the entire application stack, because if you're doing something in the real world and solving real world problems with these applications or with these techniques, it's really important that you are taking that analytical approach, that mindset into, okay, like how is this going to work in 3 months? How's it going to work in a year? And we're really excited to kind of walk you through what we've seen in sort of regards to all of those things today. So without further ado, I'll go ahead and pass it over to Max, and he's going to sort of walk through what we're seeing.
Thank you, Zach. I'm going to start giving a quick overview of the entire talk. It's meant to cover an analysis of how does open source stack up against closed source right now, how do small models stack up against big models right now, and what are the tools and techniques necessary to start figuring out which of these choices to make. If there are any questions that you have during the talk, please feel free to include them in the call chat, and we will address them towards the end in about a half hour. So really what we wanted to talk about is the fact that there's no easy way to choose an LLM right now, because we have options of whether to go with small closed source models, large open source models, large closed source models. And on some tasks, the small or the open access alternatives can be controllable and cost effective. The frontier of performance, the biggest closed source models still seem to have a quantitative edge, and we'll say what we mean there. But alternatives like small open source models can really be viable for your business if your needs are narrow and specific, but really knowing which of these options to go with and knowing whether you got positive return on investment is a bit loose at the moment. So what we really want to cover in this talk is where we're seeing these performance gaps and what are the actions that are possible to quickly right now get into a state of experimentation where you have quick and easy touch points to access these models. You have clear plans in place for how you plan to evaluate and on what data you plan to evaluate these models. And you have extra enhancements in place to make your prompts as effective as they can be and really bring the information to your LLMs. So this is an overview of everything that we're going to talk about. I'm going to begin by sort of comparing the small models and the open access models to the frontier closed source models at the largest scale. And then we're going to get into the touch points and evaluation techniques and prompt enhancement techniques towards the end. So first, this chart put together by the researcher Nathan Lambert is a quick snapshot of, on a particular test, the trajectory of the frontier of the biggest closed source models from OpenAI, Anthropic, and Google, relative to the achievement of open access models, models whose weights have been put online, such as Command R Plus by Cohere, Llama by Meta. And this is a commonly used test called MLU. It is a wide-ranging set of multiple choice questions about science, history, social scenarios, lots of things. And we can see that there's still a gap between, on the upper diagonal in the red dots, the closed source models from the big companies, and on the bottom of the chart, the green dots, which are the open access models, some of which are trained by giant tech companies as well, some of which are trained by smaller research labs. And the important trend is that performance is increasing over time. And some people see a chart like this and think closed sourced is great, but open source is just catching up, and eventually they will converge. But it's important to remember that not all tests measure the same stuff. And so while this is a very broad test of information in these models, it may not be the case that the open source models just, keep naturally continuing on all tests. So we wanted to give an example of what are the types of problems that models like GPT-4 really have an edge at right now, and it's quant tasks more clearly than anything else. So this is a demonstration of something GPT-4 does better than any of the other LLMs that we tested. You don't have to worry about reading this code or knowing too much about what I'm talking about specifically. You just need to know that this is a coding and stats task that requires some kind of numerical awareness. And GPT-4 basically does it perfectly. This is roughly how much code it would take to do this task. I have two normal distributions, two bell curves, and the prompt that I gave is measure the distance between them. And there's a formula that does this called the Jensen-Shannon divergence. There's other formulas that could do this, but I prompted for this one. And there's no one-line Python function that just computes this in popular libraries. So really the solution looks something like what GPT-4 wrote, and I gave it an A. And the types of errors that we're seeing across the board from other models that have not been trained as well in quantitative coding tasks is they might write correct Python code for this formula, but a very subtle error could show up, meaning they're not actually sampling values from the right spot on a number line. That requires knowing which distributions I'm talking about and how far to the right they're shifted. So Claude 3 Haiku, a great small closed source model, it gets an A- because the formula is entirely correct, but the values it's choosing to sample over for this quant task is just not the right area you should be sampling values for. So all the Python's correct, but the numerical awareness is not there of which distributions I'm looking to measure the distance between. This third block of code has the weakness that it makes the same sampling mistake and it is implementing the distance formula incorrectly. So this is from Llama 370B. And so this grade gets a B- because there's more than one error taking place. And then this code block here, it would have a chance of being correct, except there is no function in the scikit-learn library called Jensen-Shannon divergence. This was a hallucinated function from the DBRX model, and it's a common failure mode of LLMs writing code that they will write a function that doesn't exist, but maybe it is a function that could exist in certain popular libraries. So this is only one particular task, and it may be something that your business is not using LLMs to do anything like this, but we think it captures qualitatively what is the type of stuff that models at the level of GPT-4 can do that other models can't. It's really writing code, taking into account lots of ad hoc features of what it means for that code to be correct. Other LLMs struggle to do everything correct and avoid all the errors that can happen when LLMs are writing code. But suppose we take a step back and we imagine that we don't need LLMs to do jobs that are as quantitative or as error prone as writing code. Suppose we're talking about something much simpler, like getting an LLM to answer questions about stuff that might be on Wikipedia. This is something where we see some promise in small open access models, the kind of models that are like 5.3. This is a model produced by Microsoft. It's a fraction of the size of models like GPT-4. And here we can see a video that I saw on Twitter like a month ago, where the model is running directly on an iPhone. It's not calling out to an API. It's small enough so that the iPhone's hardware can handle it. That's a pretty exciting trend that we think is going to continue, that more models won't be universally capable, but will be trained to do certain things narrowly. And people will have hardware that can handle those models running directly. And this can offer lots of other nice features of controllability and stability. Enterprises are, they should pay attention to when they can use small open access models like this. But again, this requires the job being narrow and specific enough so that a model this small, trained on not that much data, has a chance. So that's the conclusion of the beginning of our talk, where we've just covered a bit of what it's like for small open access models to be good enough if you have a narrow job that requires common knowledge. If you have a more quant heavy job, the biggest closed source models might be what you need to look at. So that's our basic view of the gap between the frontier and the other models catching up. And so what we think is really practical and useful in order to start figuring out, well, what matters to you is you should have very quick and easy tools and strategies to experiment across the board with a variety of closed models and open models, and with a variety of small models and big models, so that you can figure out what's the best set of tools and models for your task. So we're going to cover touch points, which are just ways to access LLMs and send them prompts. We're going to cover evaluation, how you should be quantitatively measuring how one model does versus another. And we're going to talk about ways that you can be enhancing your prompts using techniques like RAG that bring more information into your prompts so that the LLMs are able to do more stuff than normal prompting can achieve. Let's begin with some touch points. And really a feature of what makes a good touch point is it should really be as simple and as minimal as possible if you're in the early stages of experimentation. You want to be able to swap out one model versus another. You want the touch point to introduce minimal complexity so that you can very quickly try out models and test all the new ones that are coming out. So a library that just does this very simple and effectively is Light LLM. This allows you to, in this screenshot, see what it's like to add either OpenAI or Cohere access to a script, and then use the same kind of format to prompt both. This is not unique to Light LLM. Lots of client libraries do this, but we think this library just deserves recognition for being minimal and very simple and getting people very quickly to a place where they can now run the same script, but swap out different LLM providers very painlessly. And that's an important thing to be able to do when you're experimenting early on. But we can see that this is really for calling out to external APIs. What's another tool that maybe helps you interface with some open source models whose weights you've downloaded locally? We think a great tool for that is Ollama. Ollama allows you to access all the kinds of models that are being open sourced by the community, all the different versions of these models at different sizes and speeds, so that you can figure out for a given model, maybe I can use a tinier, faster version, or maybe for a certain model, I need the biggest version to get maximum performance. Ollama has all the different versions of these models. And the screenshot here, I think it's, worth calling out that this is a screenshot of everything I had to do to run 5.3 on my laptop. I ran a simple pull command, which downloads the weights, and then I ran a simple run command, which allows me to just type my prompt and see my response. So I've had a great time working with this library. I used it this morning to start prompting the new CodeStrill model by Mistral. it took me no effort at all to just download it and start prompting it in my terminal. And so we think that this is a great way for, people across the industry to learn about a new model coming up and start prompting it, as soon as possible, just on their own laptop with the weights downloaded locally. And then with this tool, you can also spin up a local server, and any other applications can, ping your models via Ollama as the sort of, nice, clean interface that runs in the background. So this has been a great model helping, us experiment nice and quickly. Another touch point to really almost the entire open source ecosystem. Many of you are already very familiar with this. It's Hugging Face, specifically their library transformers, and roughly everything on Hugging Face is, in the LLM world is accessible with transformers if people have put models and weights online. And so the value that Hugging Face has brought to the community is enormous, and there is so much that you can access there. But what I wanted to show here from this example is that despite their breadth of access, they don't always have the most optimal software to run some of these LLMs on your hardware. So I have in a screenshot here that running a prompt on this cool open source model called GenStruct by News Research. This is a synthetic data generation model fine-tuned on Mistral. And I wanted to use it to generate some synthetic data for some RAG tasks. And running this one prompt on this model on my MacBook took about 1.5 minutes. And so what I wanted to call out here is that by running basically the same code and the same identical prompt, I was able to get a massive speed up running the library MLX, which is not as broad of an access point to the open source ecosystem. It's software that was written by Apple researchers to run all of the matrix math that goes into LLMs as efficiently as they can on Apple hardware. And so an extremely important trend going forward for businesses to pay attention to is if they're using hardware-aware software for running language models. You want to, when speed matters, be paying attention to, is the code we're running really meant for the hardware we're running it on? And MLX is an amazing example that's just, developed over the last 6 months roughly, of people making language model operations run very fast on Apple hardware. It's the same software that allowed the Phi 3 model to run as quickly as it did on the iPhone. So if you're not running Apple hardware, which most people are not, this is just because I was using a MacBook at work, but other amazing projects that really focus on better speed of LLM operations on their hardware, Llama C++, which is a massive project driven by the open source community with new formats for running all sorts of AI models, not just language models. VLLM is a fantastic project out of Stanford University to get more power out of GPUs and to be able to more efficiently manage inputs and outputs and speed of GPUs and memory. And Grok is a company that is really rethinking the hardware design itself, as well as the software of running language models. So it's unclear exactly what is the most important thing for you to do when you're setting up your touch point for experimentation. Most of what I've covered really only makes sense for you when you are experimenting and not when you're really deploying. For deployment, that's when you should maybe look more closely at options like VLLM. But what I hope you take away from the talk so far is that there are some very quick, minimal interfaces and tools you could use to start interacting with LLMs, and hopefully you can make it easy and as fast as possible. Now we're going to talk about evaluation. You can get fast outputs, but beyond a vibe check of just judging outputs yourself, how can you really know when one model's doing better than another? And we really think there are 3 rough buckets of evaluation strategies that we've seen emerge. And this isn't really specific to LLMs very much, but it's, I think, relevant to view these 3 buckets still. You can judge LLMs on some test based on exact correctness. Did they output exactly what we expected them to? You could judge LLMs on some test measuring, were they close to correct, where you have some notion of the distance between what they wrote and what they should have written. And then without necessarily using a ground truth answer that should have been written, you can use heuristics to measure, was the LLM's output any good? And the heuristics might really matter if, let's say, you don't know exactly what the output string should measure, but maybe a human could decide if the output string is correct. If you really have so many answers in your test that it's not feasible for a human to grade all of it, then different choices of exact correctness measurements or approximate correctness measurements could be more computationally feasible. You could also use LLMs as judges. All of these different methods have their trade-offs and things they can handle versus struggle with. Judging LLMs based on exact correctness is risky if your LLM might be using synonyms or alternative phrasings that might not be handled by your ground truth answer. And human judgment and LLM judgment are subject to plenty of biases. Like we can sometimes grade the longer answer as the better between two options. So there's no one winning formula for how to evaluate, and we really think that using a mix of heuristics and formula types is really the best way to be evaluating LLMs on your tests. A general purpose measurement that helps in a lot of the A/B testing type of evaluation is the ELO metric, and it's inspired from its use in chess, where we use it to rank chess players, not based on objectively how good are their moves, but just how often do they win against other players. And so a lot of these popular leaderboards are doing a similar thing where they're not measuring how good is an LLM's output, but they're running lots of A/B tests to measure according to online voters. They are shown two responses and they vote for which one did a better job responding to their prompt. And so this is a snapshot of the May 9th leaderboard from the chatbot arena, where anyone can go prompt two LLMs and pick who did better. And you could also follow this QR code to check out Arthur Bench, where we've set up a demo of using ELO to compare models at summarization. Summarization is a task where there's often not an objective criteria for did you summarize correctly, but we can often tell between two summaries which one's better. So ELO is a kind of nice, useful, flexible metric in scenarios like that, where you can't really judge the quality of an answer, but you can judge the relative quality between two answers. So if you're curious about how to use the ELO metric with summarization and get started testing with Arthur Bench, which is our LLM evaluation tool, you could follow that QR code there. And ELO is a cool metric because it's revealing some important patterns. The Claude 3 Haiku model, which we called out earlier, this is a great model that often can achieve a level of relative preference that matches the top models, but it's much, much cheaper than the rest of the top models. So viewing this performance cost frontier really helps kind of show the cost effectiveness of different LLMs in a more objective way than other measurement approaches. The bottleneck for evaluation is the data. So no metric can really help you if your choice of evaluation data is not well thought out. And an amazing resource that talks about how to get evaluation data for yourself that makes the most sense for your application is expressed in this blog post by Hamel Hussein. And he discusses the notion of a virtuous cycle whereby you're actively experimenting and actively redefining what it is your LLM is doing and how you're testing it. And if you can log what you are seeing while you're testing, that can form the basis of your evaluation data going forward. So it's a really great blog post that emphasizes the importance of curating your data set for maximum relevance to your application. And then beyond just relevance to specific applications, we think that an important trend is that benchmarking will be really taste-driven over time by people who have already thought through a lot of the random specific things that they would really like LLMs to be able to do. So a really cool example of this is a repo set up by the DeepMind researcher Nicholas Carlini, who was like, I started realizing that I really wanted to be able to get LLMs to do SQL queries and bash scripts and compress my JavaScript. And so he started really formalizing what are all of those tasks, and he made his own personal benchmark and leaderboard. And it's really cool because it kind of goes further than a lot of the more standard, commonly used benchmarks. And we think that it sort of marks the beginning of an important trend going forward in, what the more informative benchmarks are going to look like. They're going to, go further into some of these, cooler tasks that people would like LLMs to be able to do. All right. So we've covered a bit of the difference between the frontier of LLMs and the models catching up. We've covered how to access LLMs a couple different ways and how to think about evaluating their performance. Now we wanted to cover the cool ways that people are really bringing more capabilities just into their prompts. And the first thing that a lot of people probably think of at this point is RAG, which stands for Retrieval Augmented Generation. It is analogous to maybe an open book test that you may have taken back in school, where you have the test questions, but you also have a textbook that you can flip through and look for information from. When we do RAG, we don't have to train LLMs on all the data that we're bringing into the prompt. The LLMs can be trained however they were trained. And then with RAG, we retrieve relevant information for the question we're asking. So if I ask, where should I go to eat in New York? RAG could go search for a bunch of things from the internet or things from a database that are similar to my question, eat in New York. So you could imagine it retrieving blogs about restaurants or things like that. The schematic for how RAG works more effectively is when you think about repeatedly querying until some decision procedure can tell, hey, we have enough information to answer this question. There's a library called DSPy, which we will touch on a bit later. It is a bit complex of a toolkit for simple experimentation of LLMs, but it does a couple things very well that we're going to touch on later in the talk. What we want to take away from here is just that DSPy and other frameworks can make it very, very minimal and natural to express in Python code, I have a user question. Let me search for a couple of rounds for relevant info. Let me extend how much info I've fetched. And if I think I have enough, then I can now answer the user's question. So RAG is an extremely popular design pattern that lots of enterprises are getting value of because you can have data specific to your application that didn't need to go into the LLM training. You can see if the LLM is good enough at answering these questions just when you bring that information into its prompts. Another awesome design pattern that's emerging doesn't have to do with information brought to the prompt, but more like structuring the output from the LLM so that it's easily pluggable into something else. So a popular example of LLMs using tools is like an LLM writing a string that we can just send to a weather API. So instead of the LLM writing the question, maybe, what's the weather in New York? It writes an actual structured query into a weather API where it will fetch temperature and then city, New York. So there's not much mystical about LLMs using tools. It's really that they're writing strings that we can just map into some external system. And agents are not much more mysterious either. It's really looping an LLM using tools and then taking the output from one step and then subsequently using that as inputs to the next step in some ongoing loop with a broader goal for the agent to accomplish. So coding agents you could think of having as access to a calculator API and a little sandbox Python interpreter. So it can write calculation requests like multiplying two large numbers. And instead of an LLM having to do that, which they're bad at, it can just get the answer from the calculator. And then it can write Python scripts and then it doesn't have to write the Python outputs itself. It can write the script. The script is run by the interpreter, and then the LLM agent gets the output and can do further stuff with it. This is going to be a much bigger deal in years going ahead. And OpenAI and Anthropic and Google, they've really started training their LLMs to be able to write structured outputs like this. This is an example from Cohere's model Command R or Command R plus. These models, which are well-performing and their weights are open access, which is very cool. They've been trained to use tools, meaning that little rectangle that says action JSON there, that's the actual written string in its entirety from a Cohere command output. They've trained it to write JSON sometimes and write in plain English or any language other times, so that when you prompt it to use tools, it will use tools. And then when you prompt it to answer questions, it will answer questions. They show different prompt templates that get these different kinds of responses to come out. And this way of getting certain types of actions with certain types of prompts and it all being much more methodical and structured is a very important trend for reliability going forward. You don't have to think of structuring the output as just using a tool. You could think of structuring the output more simply as, hey, maybe I just want my LLM to pick between 3 colors and I don't want anything else to come in its output. So a library that you could check out if your needs are as simple as this is Outlines. They make it pretty simple to take open source models and run code that enforces at every moment when the LLM is sampling its next token, that sampled token satisfies a pattern. And that pattern could be valid JSON. That pattern could be each token needs to be a valid choice from the list. That pattern could be, I need the LLM to give me an object of type character, which is a Python class I just defined. All of these structures you can get with 100% guarantee if you use something like the Outlines library. To get something like that from a closed source model where you can't structure the token sampling, you have to do tricks like, give the LLM the promise of 1,000 fake dollars if it gives you valid JSON. This is a much more sensible approach where you're enforcing at every moment that the LLM is writing something that satisfies your structure. So Outlines has been a real leader in that space. Now, the last type of prompt enhancement we wanted to talk about is just showing examples of the job you need done, showing how it's done. This is a lot of information on this slide. It talks about other synonyms for giving examples in your prompt, like in-context learning or few-shot prompting. The way we think about this is you can do techniques like chain of thought, which try to get an LLM to be more accurate by thinking through things. But if you really give examples in your prompt before you ask your question, like give a separate example question and an example answer, you could demonstrate patterns that you want to be repeated in your final output. So for example, if you want an LM to do math and show its work, meaning like it writes down an intermediate equation, in these 2 example inputs here, the one on the left gives an example of that, and the one on the right just says, please think step by step. But just asking to think step by step doesn't mean you actually get work being shown. If we really give an example of that in the prompt on the left example, the LLM response shows the type of pattern we demonstrated in the prompt. Adding examples to the prompt isn't just about influencing the shape or properties of the output. You could think of prompt examples also as just being performance enhancers in a lot of scenarios. So this Google project showed that if they dumped dozens or hundreds or even thousands of example outputs into their Gemini model, which has a massive context, so it can fit all those examples, you can get something like up to 20% performance improvement on some benchmarks. And there's a limit to how cost effective this can be. We're not seeing the dollar cost of these choices here, but this is an important thing to keep in mind, that not all of the learning has to happen when the LLMs are getting trained. A well-curated set of examples included in the prompt can have the kind of impact that real model training can sometimes have. So we don't really think the industry has seen the full impact of in-context learning yet. So we think this is important for enterprises to pay attention to as context windows get bigger. But there is, a cost to choosing a ton of examples, meaning if you're talking about needing hundreds, it can be extremely tedious to know which examples to choose. This is why we wanted to mention DSPy. Among other things, it can auto-learn which examples to include in your prompt to maximize performance on a benchmark. It can also auto-learn a lot of the extra little writing hints to be included in your prompt in order to nudge benchmark scores up. So while DSPy is not the simplest library to express LLM pipelines in, it is a library where you can express the pipeline, change any piece, and then re-optimize the entire pipeline anytime anything changes. You could also then think of expressing one common skeleton pipeline and then re-optimizing a bunch of different times for different benchmark data sets. This is going to be a very important trend going forward. As pipelines get more complex, you will want to re-optimize the pipeline when you make small tweaks like changing the retrieval, changing the prompts, changing the LLM providers. So DSPy is a leader in that space. But there's another risk that we haven't talked about when it comes to models that are learning from tons of examples, which is that you're opening up an attack surface. Models can be manipulated still very easily. Anthropic has a research project that shows how you can bypass the safety training that they've done if you can fit many, many examples of falling victim to jailbreaking inside the prompt. So their models have been trained to refuse, harmful requests, but big enough context windows can sometimes open up an attack surface for jailbreaking attacks and prompt ejection attacks. So this still being a risk means it will be very, very important for enterprises building pipelines with big context window models to have really robust monitoring in place. This is a problem space that Arthur is really trying to think about for the long term. What do security systems look like with these LLMs, where you're rigorously monitoring the inputs and the outputs because risks like this still exist? With that, I thank you very much for listening to me and for taking the time to come to this webinar. I would be happy to take any questions right now.
Great, thank you, Max, so much. So we do have a couple of questions from the audience. The first one is, what exactly do I get out of using DSPy versus writing my own prompts?
Well, for using DSPy, you can write, let's say, not just a single step from an LLM response, but maybe a multi-step application where we're first maybe rewriting the user query in order to do better retrieval. Then we're doing a couple rounds of retrieval, and then we're maybe aggregating what was retrieved and maybe summarizing some stuff. And then we're finally at the end writing messages to the user based on all the stuff that was collected. If any part of your pipeline changes, such as which LLM you're using, which retriever you're using, how much context you're fetching, your prompts may not be good enough anymore if you change any one of those things. A big difference is if you switch LLMs, even if you switch LLM versions like Llama 2 to Llama 3, you probably want to prompt entirely differently. And so if you're a great prompter, keep doing what you're doing. But if you're finding it kind of slow and tedious to rewrite your prompts every time you change things, that's the value of DSPy, is you write the Python for the pipeline, and then you re-optimize the full pipeline on a benchmark data set so that you don't have to write the individual prompts. It's possible that your individual prompts are better, but it's also possible that a pretty blind trial and error process can beat your handwritten prompts. And it can maybe do this in 20 minutes instead of the handwritten prompts that you maybe worked on for weeks. So it's not guaranteed that it's better than what you can do. It's basically guaranteed that it's faster than what you can do. So it's worth trying out.
Awesome, yeah, thank you. And then a somewhat follow-up or related question, how is DSPy different from what LangChain offers?
Yeah, that's a great question. LangChain has similar connectors between the LLM answering part and the RAG part, and LangChain has lots of extra connectors that you can bring in. And so LangChain, we really think of as like attempting to be this universal LLM library where it's very broad. You can get access to all the stuff and it's all in LangChain. Whereas the value of DSPy is really that step of you have an LLM application with multiple pieces in it. And every time you change one piece, the whole pipeline might not be as optimal anymore, and you might want to rethink all the prompts. So LangChain, as far as I know, doesn't have a mechanism yet to optimize all steps of your pipeline together. And by optimizing all steps together, I mean really thinking through what's the best combination of prompts for the first LLM, for the second LLM, what's the best hyperparameters for retrieval. The value that we think DSPy brings over LangChain is that they've started building DSPy from the ground up to be the thing that optimizes all those together instead of treating optimization as separate. So their design philosophy is you need to optimize the entire end-to-end system. You can't optimize the LLM separate from the retriever. You optimize the end-to-end system. And so the value of DSPy is getting you closer to there. Whereas LangChain is more like you can build all the pipelines you want because they have broad access and integrations with everything in the ecosystem. But LangChain doesn't quite get you to the place where you can optimize an end-to-end system easily.
Awesome. Thank you very much. We've received a couple of questions about whether we'll be sharing these slides and any of the additional sort of information on them. The answer is yes. We'll be posting this webinar on YouTube, and we will be following up with the blog post that basically mirrors the content in here, and we'll have all of the links to everything that we linked out in the slides.
Yeah, and the blog will be written out, whereas me verbally, I've been talking too fast sometimes. So please, if anything was unclear, or if I was jumbling my words, please read the blog post.
Yeah, absolutely. So a couple other questions, and then we'll finish up. How do you start with adding support for third-party APIs, like a calculator for models?
So if you were ever a math student in high school or college and you needed to do a calculus problem and you didn't want to do it yourself, you could maybe write it into the Wolfram Alpha online calculator and it can just solve derivatives and integrals and things. So they have an API that can receive as a string, just like a description of a math problem, and they can return to you a written string, which is the answer to the math problem. And it's not wizardry. They have a manual function that they've built over decades that plugs in your writing into an actual real calculator app. So Wolfram Alpha is just one example of an API that can be a calculator API. There are others. The notion of a tool will apply just as much to the calculator as it will be to the weather app. The notion of a tool is just get your LLM to almost like fill out a form instead of get your LLM to free write strings. In the case of a calculator, your LLM will be filling out a form like what are the number inputs and what's the operation you would like done. So you could think of the LLM using a calculator as like filling out a form saying, I would like the addition operation between the inputs 3 and 5, and then it would get back the number 8. So this is important because LLMs on their own doing big arithmetic are going to mess up a lot of the time. But if LLMs can just fill out a calculator form, then the calculator can handle the calculation. And then the only thing the LLM has to do is figure out what are the inputs to the math problem and what are the operations required. It's not easy, but it's something that the LLMs are, trained to do at this point. It's similar to using the weather API. I would like the temperature parameter from the city of New York, and it will just write that out in a JSON dictionary, typically.
Great, thank you. Couple more. The first one, is evaluation an ongoing task, or is it just for making the initial selection?
It's definitely more an ongoing task than just making the initial selection. New LLMs are coming out all the time, and so you want to be considering alternative LLMs to the ones that you have in production right now. There could be data drift in the inputs coming into your system. So the best LLM in 2024 we could have all the identical models in 2025, but if people are throwing different questions into your application because of stuff going on in the world, then you should be conducting ongoing evaluation to see if on this new batch of inputs, your preferred LLM is actually the best option. And you also want to be thinking not just of evaluation in terms of performance, but evaluation of cost and latency. Really end-to-end system evaluation is something that, should be ongoing instead of just static one-time tests. You want live monitoring of your application, not just of the LM outputs, but all the relevant metadata like cost and latency.
Fantastic. Well, I think that is everything for us. Thank you so much, Max. Thank you for all attending. Like we mentioned, we'll be posting the link out to YouTube and sharing up all of the content in an official blog post over the next couple of days. Thank you everybody for attending. We really appreciated having the time. And if you have any questions or issues or whatever, don't hesitate to reach out. We're more than happy to talk through, this and any of the other AI stuff that Arthur provides.